Let's look at the next question, children. It's a very simple, it could be an MCQ question. It says, if A and B are relatively co-primes, A and B are relatively co-primes, that means the only common factor between A and B is 1. So there is nothing common between A and B. We have to find the LCM of MA and MB. It's a very, very simple question. We'll just follow the basic rules. MA can be written as M into A, and MB is nothing but factors M into B. Now we want to find out the LCM. LCM of MA and MB will be what is common. First we write what is common, which is M. Then we have an A, and then we have a B. So the LCM will be MAB. Very simple. Don't get confused with the terminology over there that A and B are relatively co-prime. Co-prime means there is nothing common between them. You cannot split A and B into any other factors. I hope it is understood. Let's look at another question from the chapter of real numbers. Let's read it. A merchant has 105 liters of oil of one kind, 120 liters of another kind, and 150 of third kind. He wants to sell the oil by filling the three kind of oil in tins of equal capacity. What should be the greatest capacity of each tin? First, what you need to understand, what are the different kinds of oil? What are the different quantities of the three kinds of oil? 105 liters, 120 liters, and 150 liters. He wants to fill them in tins. So he's distributing it. He's going to divide the quantity. When there is division or when there is distribution, which what are you going to apply over here? Are you going to find the HCF or the LCM? When you divide, you're going to get an answer which is smaller than what is given or bigger than what is given. Definitely, we look for smaller. We'll be expecting a smaller answer. And when it is smaller, we go for HCF. So we'll say quantity of oil of first kind or kind A. We can write here instead of first kind of kind A is 105 liters, kind B 120 liters, and kind C is 150 liters. Distribution, so we'll write here the greatest capacity. The greatest capacity would be what? Of the tin will be HCF of 105, 120 and 150. Now again, we'll factorize it. On factorization, what we're going to get? What are the factors? 5 21s are, 3 7s are, 7 1s are, 120. So 2 into 60, 2 30s are 60, 2 15, 3 5s are, and 5 1s are. Last, we're looking for 150. So again, we have 5 into 30, 5 into 6, 2 into 3, 3 into 1. So now what we are going to do? We are going to highlight what is common. So we have a 5 over here, a 5 over here, and a 5 over here. We have a 3, 3, and 3. Right? So what do we get? We get HCF is 5 into 3, 15 liters. So you are going to get, you will be, the greatest capacity of the required tin will be 15 liters. Now the question is over here. But if suppose the question continues and tells you find the number of tins so that the oil can be completely filled, will be what? In that case, we move ahead and we write a number of tins for oil of kind A will be total quantity 105 divided by 15, which is 7. Kind B, which is 120 upon 15, which is 8. And kind C, Again, we have 150 upon 15, which is 10. So the total quantity would be 7 plus 8 plus 10. Total tins would be 25. The question ends here, but this is in case the question continues. Then you know what to do, right? A similar question, if you see, we have over here. Uh, let me show it here. During a sale, color pencils were being sold in a pack of 24 each and crayons in a pack of 32 each. So one pack of color pencils had 24 in it and crayons had 32 pieces in it. You are going to buy full packs of both and the same number of pencils and crayons. So it cannot happen that you're buying one pack of pencils, you're getting 24, you're buying one pack of crayons, 32, and the quantity is not going to be same. So you will have to take more number of packs. And when you take more number of packs, the quantity will increase. So what are you going to do over here? You're going to find out the HCF or LCM. Definitely you're going to go with LCM, right? So I hope you can try this question. This is a similar question that we've done earlier. The length and breadth of a field are 42 and 18 meters respectively. Find the length of the longest rod that can measure the length and the breadth. So you have the length and breadth. Okay. We have the length and breadth. Length is 42, breadth is 18. Now we want a rod which can measure this also and which can measure this also. That means we are looking for a length of a rod which is smaller than the length and the breadth. So you're going to find HCF or LCM. We will find out the HCF. So in this case, I'm not writing the statements. We know HCF is going to be 42. HCF of 42 and 18 is going to be the length of the longest rod. See, the statement is important. Length of the longest rod that can measure the length and breadth exactly. Now, factorize, prime factorization or division, whatever you want to go with. 2 into 21, 2 nines are. Then we have 3 sevens and 3 threes are. Further, we do not have any common factors, so we stop here and we say HCF is 6. So the length of the longest rod is 6 meters. Right? I hope you all have understood, children. These were a few very important and little different questions from this chapter of real numbers. Real numbers as an individual weightage of 6 marks. So go ahead with this and practice these questions along with the questions that are there in the textbook. Okay.